Okay, welcome back to my YouTube tutorials. In this video, I'm going to take you through how to work this particular problem. So here we have this vector value function, which we are to find the derivative of this. So the question says, given that phi of x, y, z equal to x cubed y, z, and r equal to 2x squared y I minus y squared z g plus xzk. So this is a vector valued function, okay? And we are to find, okay, the partial derivative squared. So that's the second derivative of this, okay, of psi of what? R. So the product of this. So it simply means that we must get a product of this before doing the derivative. Okay, so I have solution here. So file is given to us, okay, file of y, so x, y, and then z, okay, x, y, and z equal to s cubed, okay, y, c. And we know our r is also giving us 2x squared y I, okay, I, minus y squared z g plus xz k. So from here, our main focus is to get phi of r first, okay? So you must get this, okay? It's simply the product of phi and then the differential, the function of what r, which is given to us this. So we are going to multiply this by everything here. So that will be x cubed yz multiplying with everything here, that will be 2x squared y, okay, I, then minus y squared z g plus xz k. So if you perform this, you are going to have phi of r equal to everything multiplied by this term here, that will be 2x exponent 5, then y squared z I, minus everything multiplied by this term, that will be x exponent 3, y exponent 3, z squared g, plus this multiplying with everything here, that will be x exponent 4, y, then z exponent 2. Okay, so we've been able to get this, okay. Now our focus or our goal here is to find the derivative of this. So we have here di squared of di y di z of phi, the product of this. Okay, so now you realize that we have di of this, which is very closer to this, okay. So we are going to differentiate this function with respect to what, z, then whatever we'll get, then we now differentiate it with respect to what, y. That will be a partial derivative of that. So whenever you have di of anything, if you have this symbol, we call it die, and it's simply the partial derivative of that particular function you are dealing with. So here we are going to differentiate this partially, okay, with respect to what? Z. And so that will be, so differentiate this, so die y in parentheses, die z, okay, with everything here, that will be 2x exponent 5 y exponent 2z I minus x cubed y cubed z squared j plus x exponent 4 y z exponent 2k. Okay, so we are finding partial derivative of this with respect to z. So here we have die y. Then with respect to z, we'll have this term to be 2x exponent 5 y exponent 2I, okay, minus this one. When you differentiate this partially, that will give verse 2x cubed y cubed c. Then this one, to differentiate it partially to give us 2, okay, if we differentiate this exponent will drop, that will be 2x exponent 4y, then the exponent reducing by 1, that will be c. Okay, so now we are done with this partial derivative. The next term is to differentiate this again partially with respect to y, and that will be die squared, okay, of dy die y die z, okay. This will simply give us a die of y in parentheses 2, okay, so that will be, sorry, this will go away, that will be, this simply means if you differentiate this, it will be 2 multiplied with 2x exponent 5 y I, okay, then minus this one will drop, that will be 2 multiplying with 3x exponent 3y squared z g. Then here we have plus 2x exponent 4, then z k. Okay, so simply our die squared die y die z is equal to 4x exponent 5 y I minus 6x cubed y squared z k plus 2x exponent 4 z k. Okay, so finally our answer to this particular question is die squared die y die z of 5r is equal to 4x exponent 5 y I minus 6x cubed y squared z g plus 2x exponent 4 z k. So this is the final answer to this question over here. Okay, this question, this is the final answer to this particular question here. Okay, so if you find this video useful, please kindly subscribe to my YouTube channel, like it and share it, and don't forget to hit on the notification bell so whenever I update my content, you quickly get the notification. Thank you once again for watching this video. Goodbye.